Hello and welcome to Tovi. This tutorial is going to cover the Flux gap filling tool. Now before we get started, we can look at our analysis history up here, where we began with raw data and then progressed through the various tools in the software. For example, the QC screening tool, the merge variable or meteorological gap filling tool. We averaged some variables, we did a footprint analysis, and we went back in and did some quality screening based on the footprint analysis results. All of these can be seen in previous tutorials. What's important for using the Flux gap filling tool is to make sure we have a full data sets for the drivers used in the Flux gap filling tool. So you can use this merge variable tool to make sure you have air temperature, VPD, and shortwave incoming radiation, say 100% coverage through the data set. When we're ready to do Flux gap filling, we can go into our toolbox and we can find the gap filling tool here. This gap filling tool uses marginal distribution sampling, and like all of our tools that you've seen, we have an acknowledgement icon down here on the right where we can click and find out information about the code, where it came from, the algorithms, and the publications behind it. For example, we can click here and we see Marcus Reichstein's paper and all the contributing authors. We also provide some links if you'd like to see any of these individuals' web pages or potentially reach out to ask them questions. We also have contributions from various other people that have tested the code or perhaps did some of the programming. Similarly, we have a help button like on most other tools where you can find some tips to make sure you're using the tool in the best way possible. Okay, so let's go ahead and get started. Let's first look here at the variables that are available for gap filling. We have our three flux variables: sensible heat, latent energy, and CO2 flux. We'll go ahead and start with our sensible heat. Now, for doing the gap filling, there are three key drivers used by the code and algorithm. We have our solar radiation, our vapor pressure deficit, and our air temperature. Now, these variables are collected during times when there's gaps in these flux variables. And sometimes if they're not, we've gone ahead and gap filled these key drivers. And so what the algorithm does is it will look at the VPD, air temperature, and solar radiation and compare similar measurements and ranges of these variables where there are fluxes, say plus or minus 7 days from the gap. So these tolerances are used, which are also basically settings for these particular variables, so that you're using a similar VPD in the gap as you are when you have fluxes. Same for air temperature and shortwave incoming radiation. So first we have our, for sensible heat, we have the shortwave incoming radiation as we talked about. The tolerance we have set to 20 watts per meter squared when we have lower light levels, for example, in the morning or perhaps in the evening. And then we have a higher tolerance for when light levels are higher in the range of, say, 1,000 watts per meter squared. We can be within plus or minus 50 watts per meter squared where we want to use this solar radiation. For VPD, similarly, we have a value set at 5 pascals. You can again go ahead and change this. And for air temperature, we're going to use 2.5 degrees C plus or minus. Now, remember for the water driver, we have the VPD that was collected by the eddy covariance system, but it had some gaps in there. And we had gone in and pulled in some external weather station data from a nearby weather station and created a merged variable called VPD. A merge. Now, this is 100% coverage during the gap we're showing here. Similarly, we did the same for air temperature, where we created a TA merged variable and in that one we merged the eddy covariance air temperature with the biomet air temperature sensor so that we have, again, full coverage during analysis period. So we have these three drivers set, and when we are ready we can come over here and click on the Start button. Now the algorithm is running, and it does so pretty quickly, looking at the tolerances and the data, and we're presented with some charts here. These are time series charts. You can see this is the month of July that we've been working with through this entire analysis. The blue dots indicate the original data, and the gray dots show the gap fill data. If you scroll down, this simply shows the drivers that were used. Here's our net radiation, our merged air temperature, and our merged VPD. If I go to the next node here, to the diurnals, I'm presented with an ensemble average for the month of July, here with time of day shown. Now, if I was doing this on a yearly data set, I would have 12 panels here, one shown for each month. And then I can go to this fingerprint node. And what you'll notice here is we have the sensible heat when we came into the gap filling tool. You notice there's quite a few gaps here. And we did that earlier, as can be seen with those nodes in other tutorials, where we did some QC screening by using min and max thresholds. We also did some theoretical data exclusions, where we took out some big chunks of data over a particular date range. We also did some dependency screening. And finally, we also looked at the footprint analysis and screened out some data when fluxes came from a flagged area inside our map. And here again is the gap fill data, and you can see visually the difference between the two, where all those values have been filled in. Now we can go back to the settings, and if we wanted, we can go ahead and change some of these tolerances and rerun the model, or we can simply pick another variable. Let's do the CO2 flux. Again, I'm going to use our merged variables so that we have a VPD and an air temperature and a solar radiation for the gap that we'd like to fill. I'm going to keep all the tolerances that are defaulted here. Click Start. Again, the algorithm runs. Now it's doing it for the CO2 fluxes. And we're going to be presented here with the charts again. Here we're seeing original data in the blue, a gap filled in the gray. The drivers, once again, we have the diurnal available to look at that chart as well, and to go into the fingerprints. Again, here's some original data where we had a large gap where we excluded some data, and all of that is filled in nicely here. If you want to go back and do some more gap filling or change some of the tolerances, you can click back to settings. Otherwise, go ahead and click here on the Done Gap Filling tool. And next, we're prompted to tag this particular run through the tool. We will call it FCO2 Gap Filled. And we're ready. Go ahead and click Continue. And that now it is applying those to the data set. All right, and here you will see we now have a new node in our workflow history where we did the Marginal Distribution Sampling Gap Filling tool. And you'll notice that our flux coverage has increased. I can go in and look at the flux variables, and I have this new one created called Flux for CO2 Gap Filled. And that'll conclude this particular tutorial.